Hey guys, Mr. Gran, 14.1 day 1, sine and cosine graphs. Here we go. All right, so sine and cosine graphs, they're trig functions. What do these functions look like on a graph? It actually comes from the unit circle. Now, you don't have to really deeply understand this relationship between the unit circle to really succeed in what we're going to ask you to do. However, I do want to go through some of it and give some of you guys an idea of why this works the way it does. So if we think about the unit circle, we've got a few elements to the unit circle, right? There is an angle, and for every angle, there is a coordinate with an x and a y value. And what a sine and a cosine graph do is they take that input angle as the x value and one of the x or y values from the coordinate here and use that as their y value. I'll explain that. We'll see that visually in the next slide. So for trig graphs, what's happening here is if we look at the graph of sine of x, what that is going to do is for every point on the graph, the x coordinate comes from the angle on the unit circle, and then the y coordinate comes from this y coordinate, which is really convenient. Sine is a little bit simpler than cosine. So if we look at one of those graphs and we look at some important points from it, at x equals 0, the y value is going to be 0. The height's going to be 0. It's going to start at the origin. Then at x equals 30, the height will be 1/2. At x equals 45, the height will be this, which is about 0.7. At x equals 60, y will be this, which is about 0.9. At x equals 90, the height will be this, which is 1. And then those values start to repeat as you go around the circle. And so what you end up getting is this periodic function that oscillates. It goes up and down across the graph. All right, with cosine of x, we again start with the angle as your x value, but then it takes the x value from the coordinate as its y value. So it kind of takes the stuff from the unit circle and tips it on its side. So at 0, at x equals 0, the height is now going to be 1 instead. At x equals 30, the height's going to be about 0.9. At 45, it's going to be about 0.7. At 60, it's going to be about 0.5. And then by the time it gets to 90, now the height is 0. And then those values start to repeat. They get negative, and then they get to 0, and then they come back to positive, and it just keeps going around and around and around. All right, so what does that actually look like on a graph? It looks like this. Now, this is a handy little animation. What I want us to think about when we're looking at this is the unit circle. Now, there's a lot of points on the unit circle. We're going to go down to just a few of them, the simple ones, the nice ones, where the heights are either 0 or +1 or -1. Right? So as this spins around, if we look at the sine graph first, the sine took the y value, the height from the unit circle, and translated it to this graph where the x value is now the angle. So as this comes around here, when it gets to 0, the height of the graph will be 0. Then at 90, it's 1. At 180, it's back down to 0. At 270, it's -1. Then back to 0. And it just keeps going around and around like this, right? The unit circle is one circle, but there's an infinite number of points you can derive from it, because after you get around the circle once, now it's at 360, and then it continues. It would be at 450, and also at 540, and at 630, and at 720, and at 810, and 900. And it would just keep going on and on forever. And in both directions, too. We could wind it the other direction and start getting negative angles as well from it. All right. Cosine is a little trickier to think about because it's taking that x value and translating it up here. So the x, again, is the angle, and the height is now the x value from this unit circle. So like, if you can kind of see, there's lines that sort of try to make this like turn up to here. But as it comes back around to 0, the x value is going to be 1, so the height here is 1, then 0, then -1, then 0, then back to +1, and it continues on and on like that. Okay, so what are you actually going to have to be able to do with one of these? Let's take a look at two examples. So our sine graph. We're going to start out with the important points, and then we'll fill in the rest of this. Let's get a couple of axes on here. So an x-axis and a y-axis. Now we want to set a good scale, and a good scale for regular just sine and cosine before we start doing transformations would be a height of 1 to -1. Right, because the unit circle goes from between 1 and -1, so that makes sense for our y-axis. Then we want to split it up kind of nicely to get from 0 to 360. So we'll start at 0, and the nice points, the easy points, are counting by 90s. So 90, 180, 270, and 360, also 0. All right, so our important points from that graph, the ones that I was kind of highlighting in that last one, although the animation goes kind of quick, so it might have been tough to follow. But the very first point there, at an angle of 0, the height was also 0. So right at the origin is where this is going to start. That is a very important point. So when you're graphing these are the 5 points that we're going to graph, and then we're going to connect it with a smooth line. All right, the next one is at 90 degrees, and at 90 degrees there was a height of 1, right? That's the top of the unit circle. So let's throw a point right there. The next one was at 180 degrees. The y value is back down to 0. So let's throw a point right there. At 270 degrees, this was at the bottom of the unit circle. The height was -1. And then it comes back up to 0 when it finishes at 360. So again, these are kind of the easy points. They're nicely spread out. They're evenly spread out horizontally, and then they just bounce from 0 to 1 to 0 to -1 to 0. And one thing I want to sort of highlight here is that we're only going to be graphing like a tiny chunk of this graph, right? It goes on infinitely in both directions, and these values just keep repeating. But obviously we can't graph like an infinitely long graph in real life, so we're just going to focus on one section of this. All right, so now let's connect with a smooth line, right? Try not to make this look like a saw. It should look like that, where it's smooth. It should not look like this, like a lightning bolt. That's no bueno. Okay, so now what do these other words mean that are up here? I'm going to start with the one here, the midline. What the midline is, if we think about this, this is some, it's not really symmetric vertically, but it gets split, or horizontally, but it gets split down the middle horizontally. And this line that splits it down the middle is called the midline. So in this case, the midline is just the x-axis, which has an equation of y equals 0. Now when we get to vertical shifts, we're going to move that midline up and down, but for today, it's always going to be y equals 0. The amplitude, what the amplitude is the height from the midline to the top or to the bottom of this graph, right? So from the midline to the very top of the wave, from the middle to the top, or from the middle to the bottom, right? It's sort of half the distance from the very top to the very bottom. It's kind of like the height of one hill or the depth of one valley, if you want to think about it that way. So the amplitude here is 1. Then this next thing, the period, this is a periodic function because it happens periodically. It continues, it repeats periodically. And so what one period means is the distance, the horizontal distance of one cycle of this graph. And that's what we're going to be graphing as one period. So what one period is 360 degrees. So every 360 degrees, this pattern repeats. If we just like cut and paste this and put another one right here and another one right here and then another one against it and another one against that one and line them all up infinitely long, that would be the full sine graph. Okay, let's take a look at our cosine graph then. Some of these things are going to be the same and some are going to be different. We are going to use the same axes, the same scale, although I'm going to have to redo some of it. So we're going to use this same horizontal scale. The x values of our important points are going to be the same, and we are going to go from 1 to -1 again. But now, our important points, at an angle of 0, cosine is +1. So our first point is 0, 1. Then at 90 degrees, cosine of 90 degrees is 0. So we'll put a point right there. Cosine of 180 degrees is -1. So this point, cosine of 270 is 0. So right about mya. And then when we get back to 360, we're at the same height we started with, at a height of +1. All right. And that looks like this. So some people like to remember like the difference between what a sine graph looks like and a cosine graph. A sine graph, one period of it kind of looks like an S, right? Kind of a goofy S, sideways S. And then a cosine graph kind of looks like a C that's been tipped on its side, right? Because the high points are on each end and then the low points in the middle. So you can kind of imagine that being a really weird C that's been like tipped on its side, right? Like if you, for whatever reason, drew your C's like that and then tipped it on its side, that would be a cosine graph. All right, so those are important points. That's a good example of a curved line through our points to make a good cosine graph. Amplitude, again, is 1. It's the same, right? The height between the midline and the top is still 1. The period is still 360 degrees because this pattern would continue to repeat every 360 degrees. And then the midline is the same for this one, y equals 0. All right, so big takeaways on this. Write down, make sure that you have these important points down and that you can visually see where the midline is. Like think about the middle, the horizontal going through here. That you can do this, that you know how to do this as an equation, not just 0. The midline isn't 0, it's y equals 0. It's the equation of a line. Period for both of them is 360. Amplitude for both of them is 1. Make sure that, again, you know the difference between what they look like visually, the S curve versus the sort of weird C curve, and that you could tell like which important points go with which one. It's only 5 of them, and you can put them in your notes. So just have this down and take a look at the homework quiz and let your teachers know if you have any questions.